This video is to help people who are struggling with the details of atomic structure. We'll cover how to draw basic atoms and also a little bit of the background as to how we know the structure of the atom. Okay, so if we went back to about 1900, people thought that an atom was basically a large ball of positive charge with little negative charges, the electrons, stuck onto it. This is called the plum pudding because it's not unlike a plum pudding, which is a big ball of sponge with plums stuck into it. Now, in 1911, a scientist called Rutherford did a series of experiments where he fired alpha particles at a thin layer of atoms. Now, alpha particles are fast-moving, heavy radioactive particles. If the plum pudding model was correct, these high-energy alpha particles should have just punched straight through the soft positive charge area and come straight out the other side. So that's what he was expecting to see. What he actually found is that if you fire alpha particles at a layer of atoms, roughly 1 in every sort of 8,000 bounces back and comes back at you as if it's hit something. Now, to deflect a fast-moving, heavy alpha particle, there must be something extremely dense that it's hitting. So, by working out how many bounced back, he came to the conclusion that right in the centre of an atom is a very, very dense, heavy core, and also that is positively charged. And then around that, in a series of layers, you find the negative charges, the electrons. And this is the model that we still hold to today. It's been tweaked a bit in light of various other discoveries, but the model that we're going to look at next is still basically Rutherford's planetary model. Right, so what's actually inside an atom? Well, first of all, we have the 3 types of subatomic particle. You absolutely have to know these. You've got the proton, the neutron, and the electron. The charge of these, by which we mean the electrical charge. Protons are positive, they have a charge of +1. Neutrons have a charge of 0 because they are neutral, and electrons are -1. For some reason I've been seeing a lot of exam answers featuring positive electrons. You're not going to encounter positive electrons at GCSE level. In fact, a positive electron you're not going to find really anywhere ever, because if it was positive it wouldn't be an electron. Okay, now in terms of mass, protons and neutrons both have a mass of 1. They're the same weight. But an electron has a mass which is effectively 0. It obviously does have a mass, but it's so tiny that even in the largest atom, the total mass of the electrons is much less than even 1 proton. Right, so where do we find them? Protons and neutrons make up the nucleus in the middle, sometimes called nucleons because they are found in the nucleus. And then around those we have these electrons arranged in energy levels or shells. You can put 2 in the first ring, 8 in all the others. We'll have a look at what that means in a second as soon as we get a diagram up. Sometimes people talk about layers or rings. Really the proper term we should be using is energy levels. Okay, so let's have a look at an atom and see if we can work out how we can derive its structure. So here we have the periodic table information. So if you wanted to find this out, you just look on the periodic table for lithium and you find that set of symbols. This is a correctly drawn lithium atom. Now there's many ways of representing this, and I'm going to show you a few in this video. In this one we've drawn all the particles out separately. So first of all, on the periodic table there is a key. The key tells you that the bottom number is known as the atomic or proton number. So that's the number of protons. So you can see here we have 1, 2, 3 positively charged protons in the nucleus. Now in an atom, the number of protons is also the number of electrons. They always balance out in an atom. So 1, 2, 3 electrons. 2 in the first ring, that makes that one full. So the third one has to go in the second ring. Right, finally the number of neutrons. The most common mistake here is to put 7 neutrons in because, well, we've used this number, so it must be this one. We do need the top number, but the top number is the mass number. Now if you remember that only protons and neutrons effectively have mass, if we know we have 3 protons and a total mass of 7, then we must have 4 neutrons. So here are the 4 neutrons. So that is a lithium atom. Okay, now what if the atom is much larger than a lithium? So this is fluorine. Now things are starting to get a little bit complicated here. We've got 19 particles in the nucleus. So we'll do this one the hard way, and the next time I'll show you the easy way. Okay, so again, bottom number is protons, and we have 9 of these positive charges in the nucleus. We have 9 electrons. 2 can fit in the first ring, which leaves us 7. So here they are, 1, 2, 3, 4, 5, 6, 7 in the second ring. And finally, top number is the mass, so we do top minus bottom gives us 10. We have 10 neutrons in the nucleus. Fluorine, done. Okay, so here's aluminium. Now we're getting quite big. 27 nuclear particles in the middle here. That's going to be a real pain to draw, so let's use a different form of representing that nucleus. So this time aluminium is atomic number 13, which means it's got 13 protons. So rather than drawing 13 little positive charged balls, which is going to take forever, we just write 13p. The p stands for protons. This is 13 protons. How many neutrons? Okay, well, it's 27 minus 13, that gives you 14 neutrons. There they are. And finally the electrons. Okay, so we have 13. 2 in the first. That leaves 11 left. We can put 8 into the next ring. So there they are. But that still leaves us 3. So we go for one more ring. And here are our 3 outer electrons for aluminium. Now, that's basically it. The most likely question you're going to get in a core science exam is draw this atom. If you're in additional science, you do need to know the Rutherford scattering experiment, but still you need to know how to draw atoms, because in the additional science you're going to get drawing ions, drawing covalent molecules, and if you can't draw an atom to start with, then you can't draw an ion or a covalent bond.